All right, the last thing, actually the last thing for your entire class, final video, final section, is using log scales, okay? The logarithmic scales are actually really, really cool, okay? And it's just a way to visualize data more effectively. Specifically, we're gonna talk about like log scales on a number line and something called semi-log plots, okay? Because if I'm graphing an exponential function, okay? And let's take the hypothetical about it. Let's look at an exponential function. Say we have data, and I haven't told you what our data is, okay? And I say, okay, look at this data and tell me, how big is the function when x is -4? Well, I don't know. It's a small number. How about -6? I don't know. It's a small number. Well, if we zoom in, we already have problems. This is already too big over here, right? You can't fit all the data on the graph because for exponential models, right, when x gets large, the graph goes way too big. And to go to the left, we can't tell because it's way too small. So we can't zoom in, we can't zoom out, we can't read the data. Okay. Whereas what we're going to do is model the data like this. Okay. And now look at this orange graph. This orange graph is very, very easy to read. Okay. So it's a convenient way of representing data that is used from time to time. And if you understand how to use it, it can be very nice. If you don't understand how to use it, then, well, then it's no good. And I have failed my job to you. Okay. So here's the idea. If we're looking at the graph of something like y is equal to 2 to the x, again, this is the thing that we couldn't look at very, very easily. It's kind of difficult. But if I take the logarithm of both sides, we get the logarithm of y is equal to the logarithm of 2 to the x. The left-hand side we're going to leave as the log of y. The right-hand side simplifies though. The exponent comes down, right? Just x times the log of 2, and this is just a number. Now is that second graph a graphed? So very visually, right? If our y-axis is no longer y, if our y-axis is the log of y, we can interpret this data linearly. Okay, so specifically, right, our x-axis is still x. I can click x on my keyboard. But the y-axis here is going to be the log of y. Okay, so this right here is not y, it's the log of y, whereas the x-axis is still x. Now, right, if I wanted to find out what is f of 8, what is f of 8, I can find it, I can see it. I want to see f of -8, I can find it, but you have to be careful here, right? Because this doesn't give you the y value, it gives you the log of y. So when x is -8, the log of y is -2.4. Okay, so have to be very careful then. This is called a semi-log plot. As opposed to a log-log plot where they're both logs. So we found the point -8 comma -2.4. So remember, that's our x value. This isn't our y value, it's the log of y. But we can find the y value pretty easily, right? If the log of y is equal to -2.4, we know how to solve this equation. This is a logarithmic equation. We can use the definition here. Common log, right? This is log base 10. So it's going to be 10 to the -2.4 power is equal to y, and we can tell what y is. It'll still require a calculator, but we can visualize data more easily. So it'll be less than 1/100th, because 10 to the -2nd is 1 over 100. And this is going to be a smaller number than this. So that's just kind of one way to use. That's what semi-log plots are. We're not going to talk too much about them, but it's something that you should know going forward. So more soonly applicable is going to be something like you're going to get on the homework, okay? Example 7. Find the values below on a log scale? Nope, not a log sale, a log scale. Part A, we can have some number line. Let's say 0's here and 5's here. And it's not even going to be a part A. Say one of our points here. And this is not the number line for x. This is going to be the log of x. All right. One's here at 4. One's here at negative 1.5. So these points are when the log of x is equal to 4 and the log of x is equal to negative 1.5. Again, we can just estimate these. Well, this one we don't estimate. We get it exactly. Just translate it to an exponential equation. It becomes 10 to the 4th power equals x. It becomes 10 to the negative 1.5 equals x. 10 to the 4th. That's 10,000. So this point over here is 10,000. Which, if you try to graph 10,000 on a normal number line at the same time as you try to graph this other number, your number line's you're not gonna be able to read the data. Which is one of the advantages of using a log scale, is it makes your data more readable. Again, provided there's this base understanding of how log scales work. Over here, we have to use a calculator for this one. This is going to be that x is approximately equal to 10 to the negative 1.5, which is 0.0312. Approximately. Wait, 0.0312. It's actually 0.0316. I don't know why I said 2. All right, this is 0.0316. Woof. And that's how you do these sort of problems. All right. The last thing that you're going to have to do for the homework assignment is write the approximate intensities of sound on a log scale. I wrote sail again. I had to put the C back in there again. Part A is going to be the sound of a vacuum cleaner. And that's going to be with intensity 10 to the negative 4 W over M squared. And part B, let's do it on the same one. Normally, you wouldn't be able to do these on the same one, but with a log scale, we can. Part B is going to be a jet engine, which is 10 squared W over M squared. So, right, if x is equal to 10 to the negative 4th, and if our other point is 10 squared, we want to know, if we're plotting it on a log scale, we need to know what the logarithm of these, right? We need the log of x and the log of y if we're going to plot it on a log scale. We just take the log of both sides. The log of x is equal to the log of 10 to the negative 4th. Similarly, the log of y is equal to the log of 10 squared. How do these simplify? Log x, these are inverse functions. We're just left with the negative 4. The other one, log y, they're still inverse functions. It's going to be 2. So on a log scale, we're just at negative 4 and 2. Okay. So if I have the log of a point, this is 0. Wait, 1, 2, 3, 4, 5. And negative 1, 2, 3, 4, 5. Well, this first point is going to be right here at negative 4. The second point is going to be at positive 2. So here's our jet engine. That's not how you spell that word. Here's our jet engine, and here's our vacuum cleaner. All right. And that's what it's asking you to do for those problems. All right. And you survived. Enjoy 6.7. You'll just have a quiz this week, and your final exam will be in the next week's module. Okay. Your final exam, that last week of work, there's no new material. You can spend the whole time reviewing. Okay. Feel free to reach out to me. Even over the break, it's fine. If you want to ask me questions on Slack or via Canvas about this material, I highly recommend. The earlier you can get started on it, the better you can do. And good luck.